Hello. Hello, everybody. Hello, everybody. How's it going? What's up, David? How you doing, man? How are you doing? How you doing? How's it going? How's it going? How's it going? Give a second here for everything to go out. Set up like usual. Your sound, all that kind of good stuff. Sounds rolling, all that good stuff. Give it a minute to see if anybody else filters in here, and then we'll get started. What's up, Dimitri? How you doing, man? What's up? What's up? What's up? So we'll give it a second here to let the stuff go out. Talk about some things. If you guys have any questions with anything, just shoot them off in the chat. I'll try to keep up with it there. But I'm going to talk. I'm going to talk today about evaluating expressions. Kind of just going back through a good review of a concept. But to be totally honest, I mean evaluating any type of an expression, whether it be algebraic or just a regular numerical expression. Obviously, if you had 3 plus 2 times 5, I mean, you would evaluate, meaning you would solve it. You'd use your order of operations to do 2 times 5, which is 10, and then do 3 plus 10, which is 13. Okay, so I mean that's dealing with evaluating that's a numerical expression. Numerical, in numerical means number. These are all numbers that you see. Just kind of breaking down a little bit of the actual verbiage behind everything. Sometimes seeing things that way and kind of saying and sounding things out usually kind of will help a little bit to understand things. I know that's in my specific instance, always kind of trying to sound things out and say, well, what kind of like a rhyming pattern or anything to really kind of understand. It helps to understand the click in the brain a little bit more. But needless to say, I mean, that's dealing with numerical. What we're going to talk about here, is dealing with algebraic. So if I had something like 3x plus 2, and then you said x equaled 2 or x equaled 3, we would be able to solve the algebraic expression. The reason we're using the term algebraic in this is because you're using algebra. You're using a variable, in part of the expression. That's kind of the thing there. Multiplying and dividing fractions. In what specific instance? So you mean something along the lines of 3/4 times 1/6, something like that, Dimitri? I'll give it a second. I know there's kind of a little bit of a delay there, but let me know in the chat there. I have a couple videos that are out there. If you scroll back in the channel, I have a couple things that are out there about dividing and multiplying fractions. But I'll run through it again. That's obviously a very core concept when it comes to multiplying fractions. Let me know in the chat there. It's something like that, like 3/4 times 1/6, or say like 2/3 divided by 1/6. Okay, yeah, that's no problem. We'll run through it here. Let me write this down here. Yeah, no matter what, I mean, whether or not it's spending the whole time evaluating expressions or dealing with a core concept like this, it's always good to go through. It definitely is. So if I said like 3/4 times 1/6, 3/4 times 1/6. Let me get this bottom part off of here real quick. Okay, so multiplying fractions. When you multiply two fractions, plain and simple, and I like in the video I said there a while back, multiplying fractions are the simplest part, because all you're really doing here is you're just multiplying across. You're just going across with this. 3 times 1 is going to be obviously 3. 4 times 6 is going to be 24. So the answer on this, when you multiply those two fractions together, it gives you 3/24. So the question then becomes, can you reduce the fraction? If you want to get into its simplest form, do any factors of 3 Why am I drawing a 0? Sorry. Go. Are there any factors of 3 that can go into 24 to help reduce this fraction, to get it into its simplest form? And the answer on that is 3, 6, 9, 12, 15. The answer is yeah, 3. 3 does. 3 can also be divided into 24. So to reduce the fraction, 3 divided by 3 is 1. 24 divided by 3 would be 8. So when you look at multiplying fractions, I mean, you're multiplying, again, if you're looking at my video on the screen here, you're multiplying from left to right. You're multiplying two fractions, you're multiplying the numerators across, and when you do that, you multiply the numerators across, it gives you that 3 in the numerator. Then in the bottom, 4 times 6, 4 times 6 when you multiply across gives you 24. Now, 3 over 24 is the answer. It's just not in simplest form. And I said in class before, I said, whatever teacher you have been going into the future, especially when you get into like high school and going further and further on there, obviously that's a few years away and everything. But when it comes to that, sometimes the teacher will sit there and say, well, reduce it to its simplest form, because technically you can, technically 1/8 is actually the absolutely correct answer. But I hope that makes a little bit of sense. Please let me know if that makes sense in the chat there. Please tell me yes or no if that that helps there, because I mean that does that's definitely a core concept that is worth spending time on, without a doubt, Let me see here. So then if we had 3 over 5, and then if I were to divide 1 over, let's say 7, 1 over 7. Give it a second there. Okay, makes sense. That's perfect. So here, let me get rid of the top part here. So that was multiplying on the top. Get rid of some of this extra writing here. There we go. So actually, what I'm going to do is I'm going to take this. So if I take 3/5 and I divide by 1 over 7. So when it comes to dividing, the first thing you have to do on this color here is you have to change that division sign. That division sign will now become a multiplication. There's no specific way of doing two division fractions that are division. You have to remember, keep, change, and then flip. KCF, not Kentucky Fried Chicken, not KFC, but KCF. You would KCF, keep, change, flip. Keep, change, flip on that. So on the left side, you would have 3 over 5. So you have 3 over 5. That's the keep part of it. The change, you're changing your division to multiplication. And then on the right side, you're going to flip it. You're going to make it its reciprocal. Remember that term, reciprocal, on that. What's up, James? How you doing? So when we change that last one, we change it. We flip numerator and denominator on that. They swap places there. So now I hope that this part here, I hope that this now looks a little bit familiar, since we just talked about multiplying two fractions. So now in this instance, now you multiply across. 3 times 7 is going to be 21. And then 5 times 1 is obviously going to be 5. Now, in this instance here, mattering what the directions of whatever question you were given, could you leave it in this form? I mean, you could. If that would be something to where if I were to have given you a test and said, now divide these two fractions, well, you would say, do I have to change this? Do I have to change this to a mixed number or not? Because technically that is an improper fraction. Okay, I'm going to change 21 over 5 to a mixed number. taking our denominator, just to show a difference here, our denominator of 5 will go into our numerator of 21. 5 goes into 21 4 times. 4 times 5 is going to be 20. 21 minus 20 is 1. Can 5 go into 1? Obviously, no. That 1 will now become the new numerator of your mixed number. The 5 here gets put up to the new denominator. So to go back to our initial question, the answer of what 3/5 divided by 1/7 could be, well, the improper fraction is 21 over 5. What's up, Kennedy? How you doing? The improper fraction is 21 over 5. Then when you change that to a mixed number, it's 21 over 5, or let me take myself off the screen here, or 4 and 1/5. This right here, this right here, or this right here are two aspects of the answer that you can see. Please let me know if that makes sense. Please let me know if that makes sense. You can tell me no, you can tell me yes. Just let me know if that makes sense. I have no problem going over that because that is definitely a concept that needs to be known going forward. Hope y'all are doing good. You know, that's May the 12th already, right? Yeah, let me know. I mean, it doesn't have to be just Dimitri. Let me know if that makes sense in the chat. I mean, we're talking about. I know it said in the. I know it says in the description about evaluating expressions, but you kind of took a little detour, which is okay because this is definitely something worth going over. You know, dividing, multiplying fractions. Me too. Me too, Kennedy. You know, me too. It's good to get it done with, though. You know. All right. Well, hopefully that helps. Hopefully that makes sense and helps right there. Like I said, if all else fails, send me a message, send me anything of that sort to, further go over that. I have no problem with, going, going further with that. Yes, I hear you. I hear you. Draw the, I can draw the desk. I can draw the desk, and here's the, here's, the head. Sleepy, sleeps, Z. It's a yeah. Yeah, Major, it's good. It makes sense now. It's something to where it's the repetition of doing it, seeing it, repetition of doing things. That's the way it'll make sense with that. Again, if we were in class doing this, I mean, we could spend a whole week talking about this stuff, talking about just, talking about even going further and saying, what if I had 4/5 plus 2/3? You talk about adding and subtracting. Well, now you have to say, well, let's find our common denominator and then add two fractions. We can go through. That's a whole core concept of things to go over with that too. So, yeah, that's it. Definitely, it's different computers and all that kind of stuff. It's to try to, get through what we got to try to get through here. So let me at least kind of get into a little bit. You woke up at 6 a.m. Oh my God, I hear you. It's What's crazy now is that like we're waking up, and now it's actually light outside. It's light outside at like 6 something a.m., which is absolutely crazy. But of course, this isn't going to tell the answer right when I do this here. But so this will kind of just to do this real quick. I'm going to kind of go through kind of I guess I'm going to go through kind of an example here in a little bit of time. Let me actually go back one. Now we'll start with this one. So this is going into the expression aspect of things, dealing with the expressions. Isn't that? Yeah, I hear you. I hear you. So you got here. So Mr. Grant, good old Mr. Grant, good old Mr. Grant, good old Mr. Grant wants to tile a 27 square foot area with square tiles. Let S equal the side length in feet of a square tile. So if I have a square tile, S is a side length. Well, what do you think the other side length of a square would be? Well, it's going to be S, right? It's going to be S because it's a square. All four sides are the same side with this. So use the expression 27 divided by S squared to find the number of tiles Mr. Grant needs to buy. Think about it. If I have a 27 square foot area, if this whole area is 27 squared feet, I know I messed that up really bad. 27 square foot area, and he's using these tiles. How many of these tiles is he going to need to put? And you see, I'm just trying to draw a little bit of a picture to show why we're using division, why we're using division, why we're using division to do this for the expression. Because if you did not, for some reason, know the expression that they gave you here, you have to figure out, well, what am I doing? Am I doing multiplication, or am I doing division, or adding and subtracting, finding an expression? They actually give you the expression, which helps out tremendously. So 27 divided by S squared. It's S squared because obviously in a square, if there's two side lengths that are S's, side length times side length, S times S. We talked about exponents yesterday. S times S is S squared. Okay. So when we have S squared, and it tells you that S equals 1/3, a number, yeah, a number, yes. Who names their kid Mr. Grant? Yes, Mr. Grant. Mr. Grant. It's very much of a bland, very much of a bland name. It's not like some of these other names that are on here. It's just kind of like, oh, it's Mr. Grant, Mr. Grant. So if I have 27 and I divide by S squared on this, you guys remember, when we evaluate an expression, what does evaluate mean? Evaluate an expression in this instance means we're going to be using substitution. We're going to be using substitution when we evaluate this expression. Substitution. Woohoo. So if S equals 1/3 feet, 27 divided by 1/3 squared. So now this goes back to, say, this is kind of good. We talked about the multiplying of the fraction because in our order of operations, please excuse my dear Aunt Sally, what are we doing first in this? What are we doing first in this expression here? We're going to be doing the exponent part first, because that's what we do first in this instance. So I'm going to kind of move down here, but what would be 1/3 times 1/3? 1/3 times 1/3. If you remember with the multiplication of fractions we just did, we multiply across. 1 times 1 is obviously 1. 3 times 3 is 9. So our next step is 27 divided by 1/9. So let's remember this. Here. 27 divided by 1/9. We're not done yet. Get rid of some of this extra garble off of here. This, just so I can get some room here. So we're at the step now where it's 27 divided by 1/9. Let me rewrite this up top. 27 divided by 1/9. So what do you think we do? School's better. Yeah, I hear you. This is not the most conducive thing, I know. If I take 27, obviously remember we keep, change, flip. 27 times, we flip 1/9. 1/9 now just becomes plain old 9. Okay? 27 times 9. 27 times 9 give us 243. So how many tiles does Mr. Grant need to buy? He needs to buy 243 tiles. And it tells you right there, it breaks it down. I know I covered it up with the calculator just to be funny with that. No, it actually isn't really that funny, but yeah, I mean we ran through this whole scenario right here. You write the expression, we substitute, and we evaluate. And then to divide, obviously we multiply by the reciprocal and then simplify. And you see that Mr. Grant needs to buy 243 tiles. 243 tiles. All right. You just need to catch up on your nap time, right? Got to catch up on your nap time, right? Almost there, guys. Almost there. Get to the other part I wanted to get to. There we go. There we go. All right. I mean, that's talking about dealing with evaluating expressions. Just kind of in a quick little blurb of information. Hope that kind of makes at least somewhat a little bit of a sense. I don't know why I said a little bit of a, but let's go into the packet part. I am in 3, 4, and 3, 5. 3, 4, 3, 5. Let's get that out. Right here. Right here. So let's get it. So I'm going to kind of roll through it quickly here, but just to kind of give a little bit of a review. You guys are like real good with the writing the algebraic expressions, and then I know evaluating was a little bit of a tough thing, but that's it's okay. We'll deal with that. But so when we write this algebraic expression to represent each situation in this, when we write expressions, the best thing to do, I've always said, and Miss Holden, everybody has said, we talk it out first. Talk it out that you see 22 less than. So 22 less than, that means 22 is less than. You're subtracting 22, then 5 times a number f. 5 times that number of f. So your expression is 5f minus 22. 48 times a number of game markers g. It's simply put 48 times g, 48g, a number of eggs, e, divided by 12. Talk it out, e divided by 12. Okay, 3 times the sum of m plus 7. Don't know why I did it like that. 3 times the sum of m plus 7. Okay, 3 times the sum of m plus 7. I mean, that's just, again, just repetition with writing these guys. I mean, it's it can get, it's easy to get confused with writing these, because then you think, well, what goes first, what goes next? But it's just doing it and then just kind of thinking, does it make sense? If you see 3 and then in parentheses m plus 7, does it mean 3 times the sum of meaning it's usually some grouping of something there of m plus 7. Yeah, there you go. All right, that. Let me get a couple of these down here for evaluating. So if I said for number 5, 12x minus 7, if I had 12x minus 7, and it tells you in here if x equals 4. Remember, we're substituting in 4, and then we're just using our order of operations. 12 times 4 is going to be 48 minus 7. 48 minus 7 will be 41. One more here and I'll let you guys go. X squared divided by y. If X is 4. Let's put 4 squared divided by y, which is 8. 4 squared, which is 4 times 4, which is 16. 16 divided by 8 is simply just the number 2. Okay. All right. With that being said, just remember, guys, evaluating expressions. Let me get this off the screen. There we go. I mean, just remember, evaluating expressions is about substitution and just using your order of operations. Remember, order of operations. Please excuse my dear Aunt Sally. Parentheses, parenth, exponent, multiply, division, yes, 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 add, and subtract. Yay, all that kind of good stuff right there. Okay. Guys, if you have any questions, please reach out. I'm here. I'll be happy to answer those. Um, but yeah, with that being said, I hope you guys have a good week. If I don't hear from you via email and Google Classroom and all that kind of good stuff, just keep working. Just keep working hard. You're almost there at the end of the school year here. So, like I said, stay safe, guys. Stay healthy. I'll talk to you guys soon. See ya.